Okay, so there's a lot of management implications for the relationship between marginal revenue and the own price elasticity. And we can begin thinking about that by first specifying the total revenue curve, which is price times quantity. And here we plug in the inverse demand curve. Price is a function of quantity. And from that, we can take the first derivative of the total revenue function with respect to Q. And that tells us that marginal revenue is equal to the change in the inverse demand curve with respect to Q times Q plus P. Okay, and so we're going to do some algebra to try to manipulate this function, this expression on the right-hand side, into something that tells us something about elasticity. So bear with me as I just walk through a little bit of algebra. Okay, so from this first expression, let's multiply marginal revenue, the term in brackets here, by 1, or price over price. Okay, and then let's multiply price over price through the brackets. Okay, so the first term, dp dq times q, multiplied by price over price, plus price, the second term in the bracket. It doesn't change because we're just multiplying that by 1. Okay, and since price is a factor in both of the additive components of the marginal revenue function, on that second step, we can factor it out and multiply it by this term in brackets. Okay, and once we factor out price, we have dp dq multiplied by quantity over price. And when we factor out price, we add, that becomes a 1. The second term becomes a 1. And so since, if you recall, own price elasticity is dq dp times p over q, then this first term in the bracket is the inverse of elasticity. Okay, so in this last expression, I've just called this, I've just inverted some 1 divided by the own price elasticity plus 1, all in brackets, times p. Okay, and then if we multiply that expression, price times 1 over E, where I've dropped the subscripts on the elasticity. Okay, if I multiply the expression from the last slide times 1, okay, a complicated form of 1, which is the elasticity divided by the elasticity. Okay, and then multiply that through, which gives me price times 1 over elasticity plus elasticity over elasticity, which can be rearranged to be equal to price times 1 plus the elasticity divided by the elasticity. So this expression, we're going to find that it's going to be pretty useful when we think about demand relationships for a business firm, and then later on down the road when we think about quick rules for monopoly pricing, quick monopoly pricing rules. So with this expression, we'll simplify it down to marginal revenue equals price times the expression in brackets. If you know the elasticity for the product you're producing and the current price, then you'll know where you are on the marginal revenue curve. And if you think that the demand curve for your product can be approximated with a linear demand curve, then you can figure out if you are on a positive or negative marginal revenue portion, and that can help you determine what will happen to revenues if you increase or decrease the price. Okay. So when elasticity is less than -1, when demand is elastic, then that means marginal revenue is going to be greater than 0. Okay, so let's look at a number example. So let's say the elasticity of your product, the on price elasticity of your product is -2. Okay, so marginal revenue is equal to price, and you just plug in -2 for E in this formula above. So 1 price times 1 minus 2 divided by 1 minus 2 equals price times -1 divided by -2. Well, minus divided by minus is a positive. So price, marginal revenue is 1/2 of price, and so marginal revenue is greater than 0. Okay, so if all you know is the elasticity and the price, then this formula can tell you that marginal revenue is greater than 0. Okay, let's say so what about when elasticity is equal to -1? Well, then your marginal revenue is going to be equal to 0. Okay, because if you take -1 and plug it into E in the numerator of this equation, 1 minus 1 is equal to 0, and the right-hand side collapses to 0. Okay, and now what about when E is greater than -1 and it's going to be and less than 0? Then the demand curve is inelastic and marginal revenue is going to be less than 0. So for example, let's say elasticity is equal to -0.5 or -1/2. Then plugging -0.5 into the formula above, marginal revenue is equal to price times 1 minus 0.5 in the numerator and minus 0.5 in the denominator. That's price equals 1/2 in the numerator. 1 minus 0.5 is 1/2, 1.5, divided by -2 is going to be equal to price is equal to -1, or price times -1/4 is marginal revenue, and so marginal revenue is less than 0. Okay, and that gives us this expression that as long as the demand curve is elastic, marginal revenue is positive, and when demand becomes unitary elastic, marginal revenue is equal to 0, and when demand is inelastic, marginal revenue is negative. Okay, so it's this relationship that leads to the expression that monopolists will always set prices in the elastic portion of their demand curve. A monopolist is a business firm that has a unique product with no substitutes. Okay, it's the only seller of this unique product. And so it can set price to maximize profit. And so it will always set price where marginal revenue is positive.